Hey, Steven. Can you hear me well? Hey, can you hear me? Just say yes in the chat or something. Oh, we'll start in 5 minutes. Hey, can you guys hear me? No, we'll just wait 5 more minutes before we get started. You guys can hear me well, right? The guys that just joined? Yeah, okay. Thank you. I will just wait for 2 more minutes before we get started. So before we get started with the new lesson, Was there any questions on the homework that you guys would want me to go over, or was everyone fine with mostly all the problems? If you guys want me to go over anything, I'm happy to go over it. No? Okay. We'll wait for a minute and then we can get started. Okay. Uh, yeah, we can get started. So, today we'll go over a topic that should be mostly familiar to you guys. Perimeter and area, right? But we're gonna be going over some problems and maybe some newer concepts that you guys might have not seen before. But it probably mostly is gonna be review, but there are gonna be some harder problems thrown in here and there. So let's start off with an easy problem. Oh, sorry. Let's start off with an easy problem. So let's say I have an equilateral triangle and the perimeter is 12. So what's the side length? If the perimeter of the triangle is 12 and it's an equilateral triangle. Does anyone remember from last week? Yeah, yeah. Uh, Also, if you guys could message me privately next time because you don't want to be spoiling the problem for everybody. But yeah, that's right. So because it's an equilateral triangle, right? So all the side lengths are equal to each other. So there's gonna be just 4, 4, 4. Because the perimeter for basically what the perimeter is, you just basically calculate the uh basically calculate the sum of all the lengths of a figure. So in this equilateral triangle, actually let me be more specific, as some people might have not seen this before. Uh so for an equilateral triangle, right, all the side lengths are equal. So if I label each of them x, right, uh what the perimeter is basically you calculate the sum of the lengths of the triangle and or whatever figure it is, and you set it equal to the perimeter. So the sum of the lengths here is just x plus x plus x, and that's equal to the perimeter, the given perimeter, which is 12. So now it's just easy to see why this is. So now it's just 4. So each side length is equal to 4. Does that make sense? Okay. So now we can go over a slightly more challenging problem. Uh, we'll go over here and okay. So now the problem goes like this. We have a, sorry, bad triangle there, but and say it's ABC, and then this is 30 degrees, and this is 30 degrees. So and say this is like 4 root 3. What they want us to do is find the perimeter of triangle ABC. Maybe 2 minutes on this one. This is something we covered last week, so you guys should be familiar with this as well. Or yeah, I'll just give you this side as well. Actually, you don't need side BC. You can just calculate it if you know some right angle geometry, but I'll just give it here. It's yeah, it's 4. So now the perimeter should be slightly more straightforward. I'll give it 30 seconds. You guys can post the answer in the chat if you want. And then okay. We'll go over the answer right now. It's just the pyramid should be, if you did it correctly, you should be getting something like this. This is because it's an isosceles triangle, right? If this is 30 degrees and so is this, then if this is 4, then this should also be 4. Because that's what the definition of an isosceles triangle is. So you have 4 root 3 over here. Now the perimeter is just calculating the sum of the lengths of a figure, right? So 4 root 3 over here, and then you have 4 as it, then you have BC, which is 4. But since AB is also equal to BC, AB equals BC because it's a isosceles triangle, so you have 4 over here as well. And then you get 8 plus 4 root 3. Slightly more straightforward, right? So one more. Yeah, we'll go over another example. Uh, Basically, now this is more of a conceptual problem, but you guys can read my handwriting, right? Uh, yeah. So maybe 2 to 3 minutes for this problem. This problem is slightly more challenging, so it'll be instructive for us to go over. Just say yes or no and the short reason why in the chat if you guys want to answer. Yes or no, just in the chat, and then we can go over it after at we can go over it after 3 minutes, I guess. 2 more minutes and we'll go over it. If you guys have hints as well, then that's fine as well. I also created a poll, so if you guys wanna say yes or no, then you can just say it there as well. We'll discuss at 4:18. All right. Yeah, we'll go over it. All right, it's 4:18, or whatever it is in your time. So we'll go over it now. Well, some of you answered it, and some of you said yes. Oh, sorry. Some of you said yes, right? Yes or no? The answer is actually no. Uh, here's why. Because say you have a equilateral triangle like this, right? Yeah, close enough. Say this A, this B, this C, and if you have like say the side lengths are like 3 or something, or so AB equals 3, and since it's equilateral, all the side lengths are 3. Uh, you can place so on line AC, you can have a point here, say X, right? And you can have a point here, say Y, right? So X and Y, and then so what you have to notice here is that wherever we like wherever we place Y, right, it has to be on line AB, and if it's on line AB, then it automatically shares an angle in common, right? This angle, like triangle AXY, this angle, right? So that's all, that condition is automatically satisfied. And then also basically if you place this point Y, right, really close to the triangle, you get the perimeter obviously is really, really small, right? And then you can even move N farther away from A, or Y farther away from A, however farther you want, and the perimeter just keeps on increasing, right? And then at some point, right, at some point, because X is very close to A here, at some point, right, the big at some really large distance, right, at some very large distance, maybe because AX is really small. AX is like, do you guys know this notation? It's basically saying that AX is really small compared to AC. So basically, maybe at a really large distance, that's just a arbitrary approximation, but at a really large distance, then AY, the perimeter of AYX, sorry, AYX might be equal to ABC. Now tell me, do these two triangles look similar or congruent to you guys in any way? Do these look congruent? No, right? Because one of the silence is really, really small, and the other two silents are like really, 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 really large, right? Basically, you wouldn't have for an equilateral triangle to be congruent to another equilateral triangle, both the silents have to be the same, right? Here, AX is really small. AX is very small. Hence, even if the perimeter is the same, and even if the angle they share, which is angle A right here, angle A, they both share angle A. Even if both of them are equal to each other, they might not be congruent. Basically, is the argument here. So the answer here is actually no. Hey, this was a challenging question. So, did you guys get the idea of that, or do you need me to further explain? Yes or no? Do you guys need further explanation? No? Yeah. Just indicate so in the chat. Yes or no? No? Okay. Okay. But everyone got it. Okay, nice. So this is quite a challenging question. So yeah. Okay. That's great. So we go over slightly. Uh, this is actually from the AMC8. This is an AMC8 question. Basically the question goes like this, right? Like there's by the way, ABC is equilateral. A, B, and C, right? And then there's something like this, and so this is D, this is E, and then there's something like this. These are all equilateral triangles, by the way. A, B, C, A, D, E, and E, G, E, G, F. These are all equilateral. So, and then also it's given. It doesn't. Okay, wait. Let me draw it more. Let me draw it more proportionately. Also, so it also says that a D and D is the midpoint of AC, and G is the midpoint of AE. And then basically if AB equals 4 here, so if AB equals 4, then what is the perimeter of the whole figure? Does that question make sense? Also, by the way, what's a midpoint? So like if I say D is the midpoint of AC, what does that do in terms of the side length? If people could answer in the chat, that would be great. What does being the midpoint of a line do in terms of the side length? So you want the perimeter of the figure. Yeah. What does it do in terms of the side length? Or maybe let's just take like 3 minutes maybe to like just answer this question. Maybe we can discuss as a whole. If you guys get the answer, just put it in the chat, in a private message. Don't message it to everybody else. I have 2 more minutes. One more minute. Okay, we can go over the answer now. So let's just work it out together. If so, obviously, if it's equilateral, then as we've discussed like multiple times now, BC is 4 as well, because in an equilateral triangle, of course, right? And then, well, the question I asked before is D. If D is the midpoint of AC, what does that do in terms of the side lengths of AC? Midpoint, right? Basically it cuts the line in half. So basically, if D is the midpoint of AC, AD is going to be equal to DC because it's a midpoint. Basically, it's exactly what its name says. Basically, it cuts the line in half. So if this is 4 and this is 4, and then similarly, right? AC also has to be 4. So what's AD? AD is 2, right? Because so AD is 2 here, DC is 2 here, right? Does that make sense? And then basically, yeah, okay. So and then DE. So basically now we're given that AD is an equilateral triangle. So what's the side length of DE? 2, right? Because ADE is equilateral, and then AD is equal to 2. So DE equals 2. So DE equals 2. And then EG, what's EG? I'm just gonna, like, what is EG? Yeah, 1. 1, right? And then EG, since EGF is an equilateral triangle, this is 1 and this is 1. Now, in terms of the perimeter, do you guys know like exactly how to calculate the perimeter in this figure? Like which side lengths to count for and which to not? Because you don't just go by and like add everything up and then you're done. You don't do that. You guys know which ones to add up and which ones to not. Yeah? What do you guys think? Yeah. As one of you mentioned in the chat, AD and EG is not counted because for perimeter, right? You want basically, okay, wait, let me see if I can hide. You only want this, wait, that's really, uh, you only want this part. You only want this part. So in this part, you don't count DA or EG because it's asking for the perimeter of a figure. The perimeter of a figure is basically everything to the outside, right? DAD and EEG, if you look at the figure carefully, it's towards the inside of the triangle or inside of the figure, right? Like it's not towards the outside. You only count sides that are like outside the figure. That's what the perimeter is. So because basically if you like redraw this figure, it looks something like this, right? How does it look? Yeah, okay, so it looks something like this maybe, and then you have, it looks like something like this and that, right? Yeah, okay, there's something like this. Basically this line and then this line, these are not counted because these are not because as I mentioned in the definition earlier, uh the perimeter of figure, you only calculate the sum of the side lengths. These are the side lengths of the figure, not the ones inside the figure. The ones inside the figure don't really count for anything. So here AD and EG is not counted. So if we add everything else up, we get 1 plus 1, right? Because we count everything except like EF and everything except EG, which is EF and FG. And then we have +2 plus 2 because we don't calculate AD, so we calculate everything else, and then we have this two here, CD. We have this here, so we count that because this is towards exterior of the figure, so we count that, and then we have +4 plus 4. So if you add that up, you get like 15 here. Yeah. Yeah. No. Or did I go wrong? Right. Yeah. Yeah. There's 3 ones. Sorry. Yeah. Yeah, there's 3 1s, 2 2s, and 1 4. Yeah. Yeah, because you don't, yeah, okay. Because this is 1, right? So you calculate 1 for EF. All right, let's just circle everything. We calculate 1 for EF, which is 1. You calculate 1 for FG, which is 1 right there. You calculate 1 for AG, which I forgot to do earlier, my mistake. But you don't calculate EG, but you calculate AG because AG is towards the exterior of the figure. Like it's this side and right over here. So you calculate these 3, which is 3 1s. And then you calculate this 4, which is plus 4 there. And then you calculate this 4, sorry, and 4 there. And then you calculate this 2 and this 2. So 2 plus 2. And you get something like what? Is that 3 plus 8 plus 15. Does that make sense to everybody? Oh, I'm just using Freeform. It's an iPad app. Yeah, no problem. Does it make sense to everybody though? Good. The perimeter of a figure is everything external. So you want to calculate the side lengths, some of the side lengths of the figure. Basically, here's a cool definition of the perimeter. It's basically if you walk along the boundary of a figure, the perimeter is the sum of the lengths of the boundary, like the distance you walk on. So if you walk on the boundary of this figure, right? It's gonna be messy, but you walk here, right? You walk here, and then you walk here, then you walk here, and you go there. you go there, and you're finally back to where you came from, right? You don't really walk here. That's not a boundary, right? This is not a boundary. No, this is not a boundary, right? That's basically what it is. All right, so now we can move on to area. Basically, the area for rectangle is just, if this is xy, then the area is just xy, and then square is like square, it's x squared, because like if I have a square, then all the side lengths are equal to each other. So area is just x squared, right? Area is basically the amount of space you have within the square or within the rectangle. Perimeter was looking at the outside, area is looking at the inside. And then if you have a triangle like this, then you drop an altitude right there. And does everyone know what an altitude is, by the way? Like every, like, what do you do to the side length? Like, what angle does it make with the side length? Like, what does an angle have? What does a line have to be in order to be an altitude? Yeah, it has to be 90 degrees with the side length that it's intersecting with. So this is the base. So this, if this is A, B, C, the area of this triangle is basically this. It is AM. So AM times BC over 2. Because the definition of an area of the area of a triangle is the altitude times the base, or the altitude times the base divided by 2. How can you know if this is the altitude of the triangle? Basically, the altitude makes a 90-degree angle with the base of the triangle. So whichever line makes a 90-degree angle in regards to one of the side lengths of the triangle, say, like, you could have also drawn it like this and said n, and then you could have also defined the area as Cn times AB over 2, and these would be equal to each other. So if you have any line intersecting the base or a side with a 90-degree angle, then that's an altitude. And now just going over some uh area stuff. Basically we can, yeah, okay, so now that we have gone over all the definitions, so basically if I have something like this, this is a right triangle, by the way, and if I have x, y, and z, this is 6 and this is 8, and this is, say this is xw, right? If this is xw, then find xw. Also, this is 10, by the way. Zy is 10. Zy equals 10. So what's xw? Maybe like 30 seconds for this question. Just message me in the chat. It's a pretty direct application of the, yeah, that's right. It's a pretty direct application of the area formula. Basically, let's just go over it. It's basically basically the same thing that I mentioned over here. Basically, if you have, so basically we can calculate the area of the triangle first. This is a right triangle. So if I redraw it, this is Z, this is, or yeah, okay. This is X, this is X, this is Z, this is Y, right? So so I have ZX equals 6 and this equals 8. So you see how ZX is perpendicular to XY. That means ZX is an altitude of altitude of the triangle. So basically, now we can just calculate the area, which is just 6 times 8 over 2, 24, right? And now here's the other part. Basically, now we draw another altitude, right? Oops. Now we draw another altitude to zy, and now it has zy as the base. Zy was given to be 10. So we have to find the length of this altitude. Let's just say this altitude is A. So basically, this is the length. This is the area of the triangle in terms of that altitude and that side, right? A times 10 over 2, or just 5A, right? But now we realize that these two have to be equal to each other, because you're basically recalculating the area in a different way of the exact same triangle. So these two are going to be equal to each other. So you just said 5A equals 24, or A equals 24 over 5. Does that make sense? It's basically the same way, right? It's basically the same area calculated a different way with a different altitude and a different base. You can redraw the altitude of the triangle in basically different ways. Does that make sense? Okay. Uh, so now let's go over now basically this is a cool problem that ties in both perimeter and area. It says basically you have a path like this, right? You have a path like this, and say this is a garden, right? Garden, right? Basically, the problem says the pyramid. This is a square, by the way. The garden is a square. Let me write that down. Garden, sorry, garden, square, and the path is also a square. Uh, the perimeter of the garden, P garden is 64, and the path the path surrounding the garden, like this area, right? This area, it has a uniform width, right? Uniform width. Uniform width, and this path now has an area of 228, 228, 228 meters squared, and this is meters. So now basically what the problem is asking is how many meters of fencing is required. Required to surround the path, basically. Required surround the outer edge of the path. So let me just minimize this so that you can see the whole problem here. Yeah. Now you guys can see the problem better, right? Both the garden and the path is a square. The perimeter of the garden is 64. The uh the path has uniform width, and the area is 228. So how many meters of fencing is required to surround the edge of the path, outer edge of the path? This is slightly more challenging question. I'll give you guys maybe 5 minutes to, or maybe, maybe we should revisit this. I have one more concept that I think we should go over, and then we can revisit this problem as a way of ending class. Now, the concept that I have to show you guys is same base, same altitude. And we'll go over multiple cases of each. So basically, if I have something like this, This is A, this is B, this is C, and then this is D, right? And if CD is 20, CD is 20, and BD is say 30, right? Uh, what is the ratio of the area of ABC? Also, this is how you write area, just two square brackets, two. You basically calculate you basically write area by writing two square brackets. So one square bracket, then you write the basically the name of the figure, or here ABC, and then you close it with another square bracket. So what's ACD, and then what's ABC over ABD? Can you guys see it? Yeah. So maybe 1 minute. Basically, there's only one key step in this problem, and actually, do you guys want to try this problem, or should I just go over it? Yeah, let's just go over it because of the sake of time. Basically, in this problem, there's only one key step that you have to recognize, and that is that uh the altitude in this triangle is equal for all three triangles: ABC, ACD, ABC. Sorry, ABC. Yeah, ABC, ACD, and ABD. All the altitude is the same, because if you drop an altitude like this, do you see how it's the same for every single triangle? The altitude is just the same. That's basically why you write AD as AD like that, because like AD is the same. Basically, ABC, ADC, and ABD both share the same side length AD, right? That's why all three triangles have the same altitude, and I think after this it's not too hard to like figure it out, right? You just say it's H, right? The altitude is H, and then we had the triangle area of triangle ABD, right? Which is just 30 times H over 2, 15H. And then the triangle of ABC, right? You just add these up, you get 50, and then you multiply it by the height, which is just H. You get 25H. And then for calculating the area of ACD, same thing. It's the side length is 20, and then the height is H. So there's 28 times H over 2. Now you can just calculate the ratios. It's not a big deal now. So yeah, that's basically what this problem is a good example of similar altitude, same altitude. Now we'll go over one more example which demonstrates same base. Yeah, we'll go over one example which demonstrates same base. Okay, so same base, it's let me think. Same base, if we have a triangle like this, right? Right, and then I have something like this, say. Yeah. Okay. So to demonstrate same base, let's not do this. And then basically it's like I have something like this, right? And this is 9, and then this is 12, right? And then basically two people, right? Say A and B. All right, so let's say this is C, this is D, this is E, this is this point is A, this point is B, right? And this point is whatever. It's not that's not necessary. And these are all right angles. And then say we have two people, maybe like Peter and Sam. So they wanna paint a triangle with this base AB, right? This is the base of the triangle. And then basically you tell them you're the contractor of the house, right? You tell them you have to choose either C or D, right? You have to choose either C or D as a third vertex, right? Basically, now say Peter, he says that if you choose C, you will have to paint a smaller area. Paint smaller area, right? Do you think this is a true statement? Just answer yes or no in the chat. By the way, we will be going over 5 minutes, if that's okay with you guys. So do you guys think this is yes or no? I'll release a poll. Okay. Okay, so yes or no? Do you agree with them? Yes or no? We'll just go like 10 seconds at this one. So we'll just end the poll. So the answer is actually no, because this is no, because if you choose C or D as the third vertex of the triangle, this is basically triangle ABC. If you choose C as the third vertex, and this is triangle ABD. If you choose D as the third vertex, where is the area greater? C, right? If you choose C, you have the same base. Basically, if you say this is B, the area of triangle ABC is 12 times B over 2. But here, triangle ABC, ABD, it's 9 times B over 2 because the altitude differs here. This is 9, this is 12. And this is 90 degrees to the base. So the altitude differs here. You could have also drawn if you struggle to see that the altitude of triangle ABD is actually DE over here, you could have drawn DE over here again. And then you would have seen that this is a right triangle, and then it's easier to see. So of course this is greater. So no, this is a wrong statement. Did that problem make sense to everybody? Yeah. Okay. That yeah. Then we can go over to that problem. Yeah, the garden and the square path. Just write down the answer in the chat. Oh, we will discuss at 5 o'clock. So 3 more minutes. Okay, so we'll go over the answer at 5 o'clock, and then you guys are free to go. We'll just try this problem for 2 minutes. We'll go over the answer, and that's it for our class. So basically, the problem is asking what is the total number of fencing to cover the whole path like this. So the whole path, this is the path, right? And you cover the whole path. How much fencing do you require? So this is the perimeter of the garden, and this is the area of the path, or like just this area over here, like without including the garden. So how much fencing do you require to calculate the whole path? So we'll go over two approaches in exactly 1 minute. Or yeah. Let's just go over one approach. Yeah, because time is short. Okay, so it's 5 now. We'll go over the problem. Basically, what you have to notice is since the perimeter of the garden, since P garden is 64, the side length of the side length of the garden, is 64 over 4, right? 16. Because in a square, all the side lengths are equal, and you add them all up to get 64. So if this is x, if the side length is s, right, x, right, then you do x plus x plus x plus x, and you get 64. And then it's not hard to see that x equals 16, right? And then if x equals 16, what's the area of the garden? Area of the garden is just 16 squared, right? Because in a square, you just multiply by the side by the side itself, and you get a squared. So this is the area. So if you it comes up to something like this, right? And then you're given that the area of the path is 228. Now you see that if I have something, the diagram is something like this, right? I have this area, I have this area. So if I want to calculate the area of this big square, right? I basically have all the areas I need. You just add these up and you just add the area of the garden up, and you add the area of the path up. So this is the path, right? And you basically add up the area of the garden and the path, you get the area of the total big square. What is that? 484? Yeah. Now you have the area of the big square, area big square. So what's the side length of the square? If the side length is s, right? Then again, s squared equals 484, because you basically multiply the side by itself in a big square, and you get s equals 22, right? Now what does it want? It wants the amount of fencing required to surround the outer edge of the path. But the outer edge of the path, outer edge of a square, if you want to surround this, it's basically the perimeter, right? Because you basically add all these side lengths up, and you get the total number of meters you need to surround the fencing, right? So then you just like, if this is 22, this is 22, this is 22, this is 22, and this is 22, then you get 22 times 4, 88. And that's your answer. Does that make sense? If it does, then yeah, that's it for our class today. You guys are free to go now. Bye.